Hi, welcome to the Corbettmaths Ultimate CCEA M3 revision video. In this video I'm going to go through the M3 topics from the CCEA GCSE Maths course. So if you're studying for M3, this is going to be a really useful video for you, as well as the M2 and M1 videos as well. If you're studying for M4, this is going to be a really useful video, and even M7 and M8. Now in terms of M3 is a calculator paper, so there are topics that may typically be non-calculator topics, but it's very important that if you're told to cover them, that you go through them. So in this video, if it's a topic that's typically non-calculator, I will still go through it because you could perhaps be given a question where there's a mistake and you need to spot it. So I'm going to be going through all the topics that are mentioned on the M3 topic list, and also M3 is a 2-hour exam. Now in terms of M3, here's the M3 revision checklist. This revision checklist can be found on Corbettmaths.com. Also, I'm going to put it on the description below, so if you want to find this checklist, I would go to the description below and print it out. It's very important. I would keep it as part of your notes because it's got a list of all the topics that are mentioned in M3. So you've got in blue, the algebra topics, in green, the geometry or the shape, space and measures topics, in red, the number topics, and in orange, the statistics or data handling topics. Now the aim of this video is to make sure you're familiar with each one of these topics. I'm going to spend about 3 or 4 minutes on each of them to make sure you're familiar with them, but if you do need any extra help on them, you've got the video tutorials on this checklist. So for instance, if you wanted extra help on expanding 2 brackets, video 14 on Corbettmaths will go through that in a little bit more detail. Now also beside that video link, there'll be a link to the practice questions and textbook exercises. They may be great sources of extra questions for you to practice as well. Now in terms of questions, I've created the Ultimate CCEA M3 revision question booklet. Catchy title, I know. But here we've got our practice booklet, and in the description below, if you click on that link, find the booklet which has questions on every single one of the topics I'm going to go through. So when you're watching these videos, you may want to make notes on each one of the topics as I go through them, but as well as that, you may want to practice these questions as well. Now also in this video, I mentioned the Corbettmaths revision cards quite a bit, and I borrow some of them as I'm going through the video. So if you do want to find the revision cards, there's a link to them in the description below, and the GCSE higher ones will be very useful for you if you're studying for M3. And also, whenever you're revising for M3, rather than cramming your revision, one thing that I highly recommend to students is that they do a little bit of revision every single day. And the 5-a-days in Corbettmaths will be very useful for that. Now in terms of M3, if you're revising for M3, I'd highly recommend the yellow 5-a-day booklets, which are the Foundation Plus booklets. I know they're called Foundation Plus, but that's the hardest material on the foundation paper. And then also the higher booklets, you might want to have a look at the green ones as well. So the yellow and green may be the useful booklets if you're revising for M3. Okay, let's get started. So our first topic is knowing what an identity is and be able to spot one. So that's video 367A in Corbettmaths. So we've been given a question and it says circle the identity. So here first of all we've got an equation. We've got 4x plus 1 equals 21, and we can solve this. So we can take 1 away from both sides and we'll get an answer, and if you solve this you would find x equals 5. Now because that's just got an answer, that's an equation, so it's not an identity. Now next we've got 3x minus 7 is less than or equal to 50. That's what we call an inequality, because we've got this inequality sign. We've got the less than or equal to sign. So if it's got a greater than sign, a greater than or equal to, a less than or equal to sign, they're called inequalities. That's an inequality, it's not an identity. Next we've got 6x minus 8, and that's what we call an expression. We've got these terms, 6x and minus 8. So that's just what we call an expression. And finally we've got an identity. And an identity is something that's always equal to each other. So we've got 5 bracket x plus 1 close brackets, and then we've got this symbol here with 3 lines. That's the equivalent to symbol, and then we've got 5x plus 5. And if you expand this set of brackets, so you get 5x plus 5. So 5 bracket x plus 1 is always equal to 5x plus 5. So that is an identity. It's always equal to it. So an identity is something that's always true, and that's it. So okay, our next topic. Okay, so let's have a look at our next topic. So our next topic is expanding 2 brackets. So as you can see here, we've got 2 brackets, x plus 6 and x minus 2. And we've been asked to expand and simplify them. So to expand 2 brackets, I use this approach. I take my first term, my x, and I do x times x. So x times x is x squared. Then I do my x times minus 2. And x times minus 2 is equal to minus 2x. So 6 times x is 6x, so plus 6x. And then we've got 6 times minus 2, and 6 times minus 2 is equal to minus 12. So whenever we expand these brackets, we get x squared minus 2x plus 6x minus 12. Now as you can see, we've been asked to expand and simplify, and if you look at these 2 middle terms, we've got minus 2x plus 6x. Now minus 2x plus 6x is 4x. So our final answer would be x squared plus 4x minus 12, and that's it. Okay, let's have a look at our next question. So our next question says expand and simplify 2x plus 1 x plus 4. So again, we're going to multiply both of these terms by the 2x, and then we're going to multiply both of these terms by the 1. So 2x times x. Well, 2x times x would be 2x squared, so 2x squared. Then we've got 2x times 4. Well, 2x times 4 would be 8x, so plus 8x. Now we're going to multiply both of these terms by the 1. So 1 times x is equal to x, or 1x, so that's x plus x. And then we've got 1 times 4. Well, 1 times 4 is equal to 4. So what we're going to do now is we're going to simplify these two middle terms. 8x plus x is equal to 9x. So our final answer would be 2x squared plus 9x plus 4. And that's it. Okay, so our next topic is factorising quadratics, and that's video 118 on Corbettmaths. So in M3, we're going to be factorising quadratics, that's expressions with an x squared term, where it is just an x squared term, so it's not going to be 2x squared or 3x squared, it would just be x squared or 1x squared. And whenever we factorise these quadratics, what we need to do is figure out what the two brackets were that we expanded to get that. So we want to figure out what two brackets we have multiplied together or expanded to get x squared plus 8x plus 15. What I'm actually going to do is I'm actually going to just pick two brackets to begin with, okay? And I'm going to call it x plus 4 and x plus 3. And I'm going to expand these brackets, so x times x would be x squared, x times 3 would be plus 3x, 4 times x would be plus 4x, and 4 times 3 is equal to 12. So whenever we expand these brackets, we would get x squared, and then we'd have 3x plus 4x would be plus 7x, and then we've got our plus 12 on the end. So if we had the pair of brackets x plus 4 and x plus 3 and we expanded them, we would get x squared plus 7x plus 12. Now one thing that I notice is that the 4 multiplied by the 3 gives us the number on the end, the 12. So the two numbers in the brackets at the end, the 3 and the 4, will multiply together to give you the number at the end of the quadratic. So here, where we've got our x squared plus 8x plus 15, the number here and the number here will times together to give us 15. Another thing to notice about these two numbers, the 4 and the 3, 4 plus 3 is equal to 7. They add together to give you the term in the middle. So whenever we're factorising this quadratic, x squared plus 8x plus 15, well, because it's x squared, we know there's an x at the front of both brackets because x times x is x squared. And in terms of the two numbers that follow the x's, they will times together to give you the 15 on the end, and they're going to add together to give you the 8 in the middle. So we want to find two numbers that will multiply together to give you 15 and add together to give you 8. Now, first of all, I'm thinking here it's going to be 3 and 5. Because if you had 3 and 5, 3 times 5 is equal to 15, and 3 plus 5 is equal to 8. So let's just check it. If we had x plus 3 and x plus 5, if we expanded these brackets, we would get x squared plus 5x plus 3x plus 15. And the 5x and the 3x would add together to give you the 8x. So that's it. So to factorise quadratics in M3, where it's just an x squared term at the front, you're going to factorise and put your two brackets down. You're going to put x's in the front of them, and you're going to think of the two numbers that will times together to give you the number at the end, and they will add together to give you the number in front of the x, the coefficient of x. Okay, let's have a look at another example. So this time we've been asked to factorise x squared plus x minus 6. So we're going to have two brackets, and we're going to put x at the front of both of them. And we want to find two numbers in these brackets that will times together to give you minus 6, and they will add together to give you the number in front of the x. And as you can see here, it's just x, that means it's 1. So they're going to add together to give you 1. So we want to find two numbers that will times together to give you minus 6 and add together to give you 1. So let's think of numbers that times together to give you minus 6. So minus 6, we could have minus 6 times 1, we could have 6 times minus 1, we could have 3 times minus 2, or we could have minus 3 times 2. So these are all our options which will times together to give you minus 6. But we want the one that will add together to give you 1, because it was plus x or plus 1x. So as you can see here, we've got minus 6 plus 1. Well, minus 6 plus 1 is minus 5. That's not going to be our right answer. We've got 6 plus minus 1. Well, that's going to be 5. That's not going to work. You've got minus 2 plus 3. Well, minus 2 plus 3 is 1. So that's going to be our correct option. We're going to have x plus 3 and x minus 2. So that means our answer must be x plus 3 and x minus 2, because the two numbers, our 3 and our minus 2, will times together to give us our minus 6, and they will add together to give us 1. Okay, let's have a look at our next question. So our next question says factorise x squared minus 8x plus 7. So we've got our quadratic, and we're going to start off by putting our brackets down, because we know that we're going to have brackets with x's at the front of both of them. And we want to find two numbers that will times together to give us 7, and they will add together to give us negative 8. So let's start off by thinking of numbers that will times together to give us 7. So it could be 1 and 7, because 1 times 7 is equal to 7. But it could also be negative 1 and negative 7, because negative 1 times negative 7 is 7. Now we want the option where they will add together to give us negative 8. So first of all, I know it's not going to be the top option because they will add together to give us 8. Let's check our other option. Well, negative 1 plus negative 7. Well, negative 1 going down another 7 would be negative 8. So this will be our correct option. So in their brackets, we will have x minus 1 and x minus 7. And that's it. Okay, so our next topic, we're going to look at solving quadratic equations, and that's video 266 in Corbettmaths. So to solve this equation, we're going to use the technique we just looked at, that factorization. So if you have a quadratic equation where equals 0, you can try to factorize the left-hand side, and if it factorizes, then you can solve it really quickly and easily. So let's factorize x squared plus 14x plus 45. So we'll put our brackets down, bracket, 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 and we're going to put x's at the front of both of them, and we're going to look for two numbers that will multiply together to give us 45, and we'll add together to give us 14. We could do 5 times 9, 5 times 9 is 45, and they add together to be 14. Fantastic. So we've got x plus 5, and then we've got x plus 9 equals 0. So we've factorized this quadratic, and we've got in brackets x plus 5, and then x plus 9 equals 0. Now, whenever you get two things that multiply together to give you 0, one of them has to be equal to 0. So that means that either this bracket's equal to 0 or this bracket's equal to 0. So let's look at this bracket. So you have a number plus 5, x plus 5 equals 0. So x plus 5 equals 0. Or x plus 9 is equal to 0. Either that bracket's equal to 0. So let's solve this equation. If you had x plus 5 equals 0, well, you could subtract 5 from both sides, and you'd get x equals negative 5. And in this case, you had x plus 9 is equal to 0. So if you subtracted 9 and subtracted 9, you'd get x equals negative 9. So if you had this equation, x squared plus 14x plus 45 equals 0, we've got two possible answers, and they are x equals negative 5 or x equals negative 9. And one other thing to note is sometimes I take a little bit of a shortcut whenever I'm doing these questions. So if I had x plus 5 and I'm trying to find when that bracket's equal to 0, I just know it's negative 5 because negative 5 plus 5 is 0. So I would often take a bit of a shortcut. So whenever I'd be doing these questions, I would often just go straight to this point here. So I would say, well, x plus 5 is 0, so x equals negative 5. Or, and in this case, I know that it'd be negative 9 plus 9 is 0, so I just jump to x equals negative 9. And that's it. Okay, so let's have a look at our next question. So our next question is to solve x squared minus 4x minus 12 equals 0. And that's great because the equation, the quadratic, equals 0. If it's not equal to 0, you'd want to make it equal to 0. And then let's try and factorize this left-hand side. So let's put our brackets down and put equals 0. So we'll put our x's at the front of both brackets, and we're trying to find two numbers that will multiply together to give us negative 12, and they'll add together to give us negative 4. And 2 and minus 6, well, negative 6 plus 2 would be negative 4, so that's going to be our option. So our brackets will be x plus 2 and x minus 6. Now we're trying to find when each of these brackets could be 0. We know this bracket would be equal to 0 whenever x is equal to negative 2, because negative 2 plus 2 is 0. And for this bracket, we know it will be whenever x is equal to 6. So it would be x equals 6, and that's it. So x equals negative 2 or x equals 6. Okay, let's have a look at our next topic. Now, this actually isn't really a different topic. This is really a special case. So this is the difference between two squares, and this is video 120 on Corbettmaths. So what I'm going to do is I'm going to expand these brackets where I've got x minus 7 and x plus 7. Now, I've just chosen these brackets where we've got x minus and an x plus, and then the same number. And I just want to show you what happens whenever you have this case. X times x is x squared. X times positive 7 will be plus 7x. Then we've got minus 7 times x, that's minus 7x. And then we've got minus 7 times 7. Well, a negative times a positive is a negative, and 7 times 7 is 49, so it's going to be minus 49. And whenever we look at our two middle terms here, we've got 7x minus 7x. Now, they will give you 0. Whenever you do 7x, take away 7x, that's 0. So we would be left here with x squared. This and this cancels out, and we're just left with minus 49. So if you expand in brackets where you've got an x and then the same number, but then one with a plus sign and one with a minus sign, the two middle terms will cancel out. Now that's very useful because sometimes we can factorize expressions like this, and it's called difference between two squareds, because whenever we expand these brackets, the answer will always have a squared term, so x squared, and maybe a square number, and then you'd have a takeaway in the middle, so that's your difference. You're taking away the difference between two squares. Okay, let's have a look at some factorizing using this then. Okay, so our first question says factorize x squared minus 49. Okay, so we've just done that one actually. So we know whenever we expanded x minus 7, x plus 7, we got x squared minus 49. So if we were asked to factorize this, our answer would be x minus 7 and x plus 7. And the shortcut would be, well, we had x squared, so the square root of x squared is just x, so that goes at the front of both of them. And then we've got 49, so you square root 49, that's 7, so you know that it's going to be 7 at the end of both brackets. And then you put one with a plus sign and one with a minus sign, and that's it. So if I wanted to factorize x squared minus 9x, I would put two brackets down. I'd square root both terms because they're both squares. So square root of x squared is just x and x. The square root of 9 is 3 and 3. And we put one with a plus sign and one with a minus sign. And it doesn't matter which way around they go. And that's it. So if we were to factorize x squared minus 9, the answer would be x plus 3, x minus 3. Okay, next we've been asked to factorize x squared minus 36. So again, bracket, 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 x, x, because the square root of x squared is x. And then 36, well, the square root of 36 would be 6. So 6 and 6, one with a minus sign and one with a plus sign. That's it. Okay, and our last one's to factorize 64 minus x squared. And this is just to show you that it's the difference between two squared, so it doesn't have to be x squared at the beginning. It could be the other way around. So let's factorize, and we'd get the square root of 64 is 8, so 8 is going to be at the front of both brackets. We've got our two squares, so one's going to have a plus sign and one's going to have a minus sign. And the square root of x squared is x. So it's going to be 8 plus x and 8 minus x, and that's it. Okay, and just one other question that I want to show you, it's just an interesting one. We've been asked to factorize x plus 4, close bracket squared, plus 6 bracket x plus 4. There's been a question like this before. Now some students, whenever they see this, they would expand the brackets, so they would expand this to get x plus 4 multiplied by itself, and then plus 6 bracket x plus 4. They would expand the two brackets here. Well, x times x is x squared. X times 4 would be plus 4x. 4 times x would be plus 4x, and 4 times 4 is plus 16. And then on this bracket, they would expand this as well. So we would just remember here, this is like expanded brackets in M1, where we're just multiplying the bracket by a number. So 6 times x would be plus 6x, and 6 times 4 is equal to 24. So we've expanded our brackets, our two brackets and our one bracket. And then if we simplify this, we get x squared plus, and then we've got 4x plus 4x plus 6x, so that's 14x. And then in terms of our numbers, we had 16 plus 24, so that's going to be plus 40. And then if we factorize this, well, just like before, we do bracket, 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 and put x's at the front of both of them. And we're looking for two numbers that will times together to be 40 and add together to be 14. Would that be 4 and 10? So plus 4 and plus 10. So that's how some students would tackle a question like that, where they could expand it and then try and factorize it, and that would work. Okay, let's have a look at our next topic. So our next topic is forming quadratic equations, and sometimes we have to form quadratic equations from information. Now we've done the same with linear equations, now we're just going to do it for quadratic equations. And our question says, Fred is y years old, and his brother Barney is 5 years older than Fred. So he's going to be 5 years older than y, would be y plus 5. And it says the product of their ages is 750. Well, that means if we multiply them together, we get 750. So that means that y times y plus 5 is equal to 750. And the question says, set up an equation to represent this information. So we've done that. And it says, solve it to find Fred's age. So we just need to solve this equation now. So this perhaps would be part A to get this, and then part B is to solve it. So let's multiply out our brackets. So y times y is y squared, and y times 5 would be plus 5y. That equals 750. Now this doesn't equal 0, so we can't factorize this yet. So what we're going to do is we're going to subtract 750 from both sides of the equation. So that would give us y squared plus 5y minus 750. And on our right hand side, we'd have that's equal to 0. Now we're going to factorize this left hand side. So factorizing this, well, we want two numbers that will multiply together to give us negative 750, and they'll add together to give us 5. So bracket, 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 bracket equals 0. At the front of both brackets, we're going to have y. And now we're going to think of two numbers that will times together to give us minus 750 and add together to give us 5. So minus 750, well, so we could have 75 minus 10, so they would times together to give us minus 750, but they would add together to give us 65. Whenever we add them together, the result's a bit sort of larger than we want it to be. We want the answer to be 5. So let's try minus 30 and 25. And if we multiply minus 30 by 25, we get minus 750. But when we add them, we get negative 5. Because negative 30 plus 25 is negative 5. But we want it to be 5, so let's try 30 and negative 25. Again, when we multiply these together, we get minus 750. And when we add them together, we get 5. So that's it. So that's perfect. So we could write y plus 30 and y minus 25, like so. Now we want to solve the equation, so we're going to then solve this. So the answers would be y equals minus 30, because minus 30 and 30 would add together to give us 0, or y would be 25. So that means our possible answers are y equals minus 30 or y equals 25. Now in this case, it's Fred's age. Now Fred can't be minus 30 years old, so that can't work. So Fred would have to be 25. So the question said find Fred's age. So we've got y is equal to 25 and Fred is y. So Fred is 25 years old, and that's it. Okay, let's have a look at our next topic. Okay, our next topic is algebraic fractions, and that's videos 22, 23 and 24 in Corbettmaths. So here we've got an algebraic fraction. It's a fraction with algebra, and we've been asked to simplify it. That means to cancel it down. And whenever we're cancelling down fractions, so we tried to divide the numerator and the denominator by the same thing, so they get simpler. So as you can see here, if we look at the top here, we've got x minus 3 times x plus 2, and on the bottom we've got x plus 2 plus x plus 9. Now as you'll notice, we've got two brackets that are the same. We've got this x plus 2 and x plus 2. So if we divide the numerator of this fraction by x plus 2 and the denominator of the fraction by x plus 2, we can cancel it down. So let's divide it by x plus 2, and that just means, well, cancelling it out would give us x minus 3 on the top and x plus 9 on the bottom. Okay, so our next question is to simplify x squared minus 2x over x squared plus 2x minus 8. So this time we've got to factorise before we can cancel it down. So let's factorise it. So our numerator, we can just take x out as a common factor. So that's going to be x bracket. And then if we divide both of these by x, we get x minus 2, close brackets. And then the denominator, we can factorise it. So that's going to have two brackets. We can have x's at the front of both of them. And we want to find two numbers that will times together to give us minus 8 and add together to give us 2. Now I'm thinking minus 2 and 4, because minus 2 and 4, they will multiply together to give us our minus 8, and they will add together to give us our 2. So that means it's going to be x minus 2 and x plus 4. And that's great because as you can see, we've got x minus 2 on the numerator and we've got x minus 2 on the denominator. So we can divide both the numerator and denominator by x minus 2. So that means they'll cancel out. And then you'll be left with x on the numerator, and on the denominator we'll be left with x plus 4. And we don't write the brackets, we just write x plus 4. And that's it. Okay, our next topic. Our next topic is algebraic fractions, but this time we're going to look at multiplying algebraic fractions. So remember, to multiply fractions, we multiply the numerators and multiply the denominators. So we've got simplify x over 7 multiplied by x over 3. So let's multiply the numerators. Well, x times x is x squared. And on the denominator, we've got 7 times 3, that's 21. So the answer would be x squared over 21. This time we've got 3x over 2 multiplied by 5x over 6. So this time, again, we're going to multiply numerators. 3x times 5x, well, that's going to be 15x squared. And then multiplying our denominators, 2 times 6 is equal to 12. Now, one thing I noticed on this fraction is we've got 15 on the numerator and 12 on the denominator. Now, they're both divisible by 3. So we can actually cancel down this fraction by dividing both the numerator and denominator by 3. So that will give us, if we divide both of them by 3, 5x squared over 4, and that's it. So the answer would be 5x squared over 4. Okay, let's have a look at our next question. So our next question says to simplify 1 over 2x multiplied by x squared over 3. So again, multiplying the numerators, 1 times x squared is x squared. And on the denominator, 2x times 3 would be 6x. So we've got x squared on the numerator and we've got 6x on the denominator. So we can actually cancel down this fraction. So you could divide the numerator and denominator by x. So if you did that, you'd be left with, on the numerator, x, and on the denominator, if you divide this by x, you'd be left with 6. Another way to look at it would be you could just divide the x squared by x, and that would leave you with x. And then again, that would just leave you with x over 6. This time we've been asked to simplify x minus 3 divided by x plus 4 multiplied by x plus 4 over x plus 1. So let's multiply these together. So I'm going to write x minus 3 multiplied by x plus 4 over x plus 4 multiplied by x plus 1. Now, one thing I've noticed is we've got the same bracket on the numerator and denominator, so we can cancel down this fraction, so we can cancel those out, and that would leave us with x minus 3 on the numerator and x plus 1 on the denominator, and that's it. Okay, let's have a look at some questions now where we're dividing algebraic fractions. So we've got x minus 2, and we've got divided by, remember whenever we're dealing with fractions, we multiply by the reciprocal of the fraction we're dividing by. So we're going to change the divide to multiply, and we're going to find the reciprocal, which means flip over the second fraction. And then we just multiply, so if x times 3 is 3x, and then on the denominator we've got 2 times 2, which is 4. So our answer would be 3x over 4. So when we're dividing algebraic fractions, we change the divide to multiply and find the reciprocal of the fraction we're dividing by. Okay, our next question. We've been asked to simplify 3x plus 9 over 2 divided by x plus 3 over 4. So again, we're going to keep the first fraction the same, 3x plus 9 over 2 times by, and finding the reciprocal of the second one, we're going to have 4 over x plus 3. Now when we multiply these together, we get 4 bracket 3x plus 9, close brackets, over 2 bracket x plus 3. Just putting them together. Now one thing that I've noticed is we've got a 4 and a 2, so we can divide both the numerator and denominator by 2, and that would give us, on the numerator, if we divide the numerator by 2, we get 2 bracket 3x plus 9, and on the denominator we'd just be left with x plus 3. Now another thing is 3x plus 9 will also factorise. If we had 3x plus 9, we could take 3 out as a common factor. They're both divisible by 3. It would give us 3 bracket, and dividing both of them by 3 would be x plus 3. So if you've got 3x plus 9, that's the same as 3 bracket x plus 3. But we had 2 lots of that. So instead of having 3 lots of x plus 3, we're going to have 6 lots of x plus 3. So it's going to be 6 bracket x plus 3. Another way to look at it is if we take the 3 out, we could do 2 times 3 is 6, and that's why there's a 6 in front there. But that's divided by x plus 3. Now another thing to notice is we've got x plus 3 on the numerator and the denominator, so we can cancel those out. So the answer would just be 6. And I think that's fantastic. We had this complicated algebra, and the answer would just be 6. Now, I want to sort of show you another approach to this question. So one thing to notice is also, rather than multiplying and then cancelling down, you can actually cancel down at this point here by cancelling down the numerator of this fraction and the denominator of this one, and the numerator of this fraction and the denominator of this one. Because when we multiply them, they're going to be together on the numerators and the denominators anyway. So if you had 2 and 4, you could divide both of those by 2, and that would give you 1 and 2. And here, if you had 3x plus 9 and x plus 3, you could factorise this to get 3 bracket x plus 3. And then if you cancel down these ones, well, you could divide both of them by x plus 3. So you'd be left with, here, 3 over 1 multiplied by 2 over 1. Because obviously you divide this by x plus 3, you'd be left with 1 there. And the answer would again just be 6 over 1, which is 6. So as long as there's a multiplication, you can cancel down in that technique where you cancel down the numerator with the denominator of the other one and the numerator by the other denominator, and so on. Okay, so we've looked at simplifying algebraic fractions, we've looked at multiplying them and dividing them. Let's look at adding and subtracting them. So our question says simplify x plus 4 over 3 plus x plus 1 over 2. So to add algebraic fractions, they need to have the same denominator. If we had 3 and 2, a common denominator would be 6, so 6 and 6. And to have a 6 on this denominator, we would need to double both the numerator and the denominator. To get from 3 to 6, you'd multiply by 2, so we need to multiply this by 2. Multiplying both of these terms by 2 would give us 2x plus 8. And to get from 2 to 6, you'd multiply by 3, so you'd need to multiply these by 3. And multiplying these both by 3 would give us, well, 3 times x is 3x, and 3 times 1 is plus 3. Now we can just add them together, so you know we're going to have 6 on the denominator, and 2x plus 3 would be 5x, and 8 plus 3 is equal to 11. So our answer would be 5x plus 11 over 6. Okay, so our next question. Is x plus 1 over 4. Subtract x plus 4 over 6. So if we want to find a common denominator, well, 4 and 6, well, I think 12 would be a good choice. So 12 and 12, and it's take away. Now to get from 4 to 12, we multiply by 3, so we need to multiply both of these by 3. So 3 times x is 3x, and 3 times 1, well, plus 3. And to get from 6 to 12, we double it, so we need to double the numerator. So doubling x and 4 would be 2x plus 8. And again, we want to subtract, so we're going to have equals, and we're going to have our denominator of 12. In terms of the numerator, we've got 3x take away 2x, and 3x take away 2x is 1x, or x. And then we've got 3 subtract 8, and 3 subtract 8 will be minus 5. So the answer would be x minus 5 over 12. Okay, so we've looked at algebraic fractions, and now we're going to look at some equations that involve algebraic fractions. So we've got solve x plus 5 over 3 plus x plus 1 over 2 equals 8. So whenever you've got an equation like this, I would deal with the left-hand side to begin with. So I would look at these algebraic fractions and I would simplify them. So we're going to give them a common denominator of 6 and 6. To get from 3 to 6, you multiply by 2. So let's multiply both of these by 2. So that would be 2x plus 10 on the numerator. And for this fraction, to get from 2 to 6, you multiply by 3. So multiplying both of these by 3 would give us 3x plus 3 equals 8. So as you can see, we've written both fractions with a common denominator. Okay, so now let's focus on this left-hand side and write this as a single fraction. So let's just put a big line and 6 on the denominator. And we're going to do 2x plus 3x. 2x plus 3x is 5x. And 10 plus 3, well 10 plus 3 is 13, so plus 13. And that still equals 8. So we have just combined this left-hand side as a single fraction. Now we want to solve it. So because we've got this big divide by 6, I want to get rid of that. So I'm going to multiply both sides by 6. I'm going to multiply the left-hand side of this equation by 6 and the right-hand side of the equation by 6. So I'm multiplying the left-hand side of the equation by 6 to get rid of the big divide by 6. That would just leave me with 5x plus 13. And on the right-hand side of the equation, I had 8 times 6, and 8 times 6 is 48. So that equals 48. Now I just want to solve this like an M1 equation, so subtract 13 and subtract 13, and that will give me 5x equals 35, and divide by 5 and divide by 5, and you get x equals 7, and that's it. Right, so sometimes in M3 you might have to form equations involving fractions and then solve them. So we've got a box that contains only red and green counters. There are x red counters and there are 8 more green counters than red counters. Well, if there's 8 more green than red, well, if there's x red, that means there's going to be x plus 8 green. It says a third of the red counters and half of the green counters are removed from the box. And there are now 109 counters left in the box. So if we had x counters to begin with and a third of them were removed, that means that there's going to be 2/3 of the counters left, so 2/3 of x, and you could write that as 2/3 of x, like so, or alternatively you could write it as 2x over 3, because if this is x over 1, 2/3 times x over 1, it would be 2x over 3. Next, it says half of the green counters were removed from the box. So if we had x plus 8 to begin with and half of them were removed, we've got half left. So that means there'd be x plus 8 over 2 left in the box. And it says that the total of those is 109. So if we add those two together, we get 109, like so. Now, as I said, we could write this first fraction in a different form. We could write it as 2x over 3. Okay, so let's solve this equation. So we want to have a common denominator. With 3 and 2, we're going to go for 6 and 6, and we're going to add them together. Well, to get from 3 to 6, we would double it. So we're going to double the 2x, that's 4x. And with this fraction, to get from 2 to 6, we multiply by 3, so we're going to multiply the numerator by 3 as well. So 3 times x, 3x, and 3 times 8 will be plus 24, and that equals 109. Next, let's combine it as a single fraction. So we're going to write over 6. 4x plus 3x is 7x, and then we've got plus 24. So we've written it as a single fraction, and that equals 109. Next, we want to get rid of this divide by 6. So let's multiply both sides by 6. So multiplying the left-hand side by 6 just gets rid of this divide by 6, so we'll be left with 7x plus 24. And on the right-hand side, we would have 109 multiplied by 6 would be equal to 654. Next, we want to get the x on its own, so let's take away 24 and take away 24. And when we do that, we get 7x equals, and 654, take away 24 will be 630. And then divide by 7 and divide by 7, and we get x equals 90. So we know x is equal to 90. Let's have a look and see what the question says. It says, find out how many green counters were in the box to start with. So we had x is 90. And we had that there was x plus 8. That's going to mean there was 98 green counters to begin with. And that's it. Okay, our next topic. So our next topic is looking at the equation of a line. So in M1, we looked at how to draw straight line graphs. In M2, we've looked at how to find the gradient, and we've looked at the y-intercept as well. Now what we're going to do is we're going to put it together to look at the equation of a line. So the equation of a line is in the form y equals mx plus c. So for instance, something like this, y equals 4x plus 3. So in M1, you could have been asked to draw this by making a table and using values for x and multiplying them by 4 and adding 3 and getting the values for y and plotting them. Now what we're going to do is we're going to look at this equation. So whenever you got it in the form y equals mx plus c, the number in front of the x is the gradient. So if I had the line y equals 4x plus 3, the gradient of that line is 4. And you'll remember from M2, that means that for every 1 square you go across, or 1 unit you go across, the graph goes up 4 units. So you go across 1, it goes up 4, and so on. And then our plus c is the y-intercept. This shows you where the graph crosses the y-axis. So for this graph here, this graph would have y equals 4x plus 3, has a gradient of 4, and it crosses the y-axis at 0, 3. It has a y-intercept of 3. Now here's part of the Corbettmaths revision card on the equation of a line, and you've got y equals mx plus c, where m's the gradient, so this number's the gradient and c is the y-intercept. And if we had this line here, if we wanted to find this equation, well, first of all, we would find the y-intercept. It crosses the y-axis or meets the y-axis at 1, so that means that it's going to be plus 1 on the end. In terms of its gradient, well, we can make a little triangle, and we can do rise divided by run. And if the rise was 4 and the run was 2, well, 4 divided by 2 is 2. So that means the gradient of this line is 2. For every 1 you go across, it goes up 2. 1 you go across, it goes up 2. So the gradient of this line is 2. So the equation of this line would be y equals 2x plus 1. So let's find the equation of this line that's been drawn on the grid. So we know it's going to be in the format y equals mx plus c. We know that m's the gradient, so let's find the gradient to begin with. So let's make a little triangle. So let's choose 2 good points. I think that a good point would be this one here at minus 1, 1, and another good point would be this one here. You could have also chosen 0, 4. So I'm going to make a little triangle, so going across and up. And for my triangle, it's got a run of 2. It goes across 2 units, so it goes from minus 1 to 1. It's got a run of 2. And the height, it goes from 1 up to 7, so that's got a rise of 6. So for the gradient, we've got rise divided by run. So m equals rise over run. So it's going to be equal to the rise 6 divided by the run 2, and 6 divided by 2 is 3. So the gradient of this line is 3. So we know it's going to be y equals 3x. Now in terms of the y-intercept, it crosses at 4, positive 4, so it's going to be plus 4. If it crossed down here at minus 1, you would write minus 1 and so on. If it crossed through the origin 0, you wouldn't write anything, you would just write y equals 3x. But this graph, it crossed, it had a y-intercept of 4, so we wrote y equals 3x plus 4, and that's it. Okay, our next question says, a straight line with gradient minus 2 passes through the point 1, 5. Find the equation of the line. So we know, first of all, it's a straight line. So we know it's in the form y equals mx plus c. So we know that the answer is going to be y equals something x plus or minus something. And it says it's a straight line with gradient negative 2. So we know it's going to be y equals minus 2x and then something after it. And it passes through the point 1, 5. And it says find the equation of this line. So we need to find this y-intercept. And that's where the straight line meets the y-axis. There's 2 ways which I would typically do this question. One is by looking at the gradient. The gradient's minus 2. So that means that this graph is actually going down. So we've got a x and y axis. It's got a gradient of minus 2. So it's coming downwards like so. And we know it goes through the point 1, 5. So it goes through the point 1, 5. So because we know the gradient's 2, that means for every 1 you go across, it comes down 2. You go across 1, goes down 2. So for this point here, if we want to find where it crosses the y-axis here, so the y-axis, we know that it's gone across 1 and it's come down 2, and it's now got a height of 5. That means it must have had a height of 7 to begin with, because it must have had a height of 7 to go across 1 and come down 2 to now have the height of 5. So that means that our y-intercept would be 7. So the equation of our line is y equals minus 2x plus 7. So one approach is to know what the gradient means and to look at the point you've been given and to work out where it would have crossed the y-axis. Now there is another approach, and this is actually the approach that I would typically use, and that is whenever we knew it was y equals minus 2x plus something, I would just write plus c, which stands for the y-intercept. And I know that the point that they've given me is 1, 5. So I know that it has an x-coordinate of 1 and a y-coordinate of 5. And we can substitute these in to our equation. So we can, instead of writing y equals, we could write 5 equals. So 5 equals. And then next, we know we've got minus 2x. So that's minus 2 times whatever x is. And x is equal to 1. So minus 2 times 1 is equal to minus 2. And then we've got our plus c. And then we want to find what c is, our y-intercept. Well, we want the c on its own, so we want to get rid of this minus 2, so we'd add 2 to both sides of this equation, and you get 7 equals c. So c is equal to 7, so you get y equals minus 2x plus 7. And the great thing about this approach is we were quite lucky in this question. Whenever it was 1, 5, that we could just go across 1 square and go up 2 and find out that it was 7. This approach means that you can just find it out quite quickly and easily, no matter where this point is. Okay, let's have a look at our next question. So this time we've been given a straight line passes through the points 3, 8 and 5, 20. And we've been asked to find the equation of the line that passes through those points. So again, we know it's going to be in the form y equals mx plus c. So we want to find the gradient of the line that passes through these points, and we want to find where it crosses the y-axis. So first of all, let's find the gradient. Okay, so let's do a little sketch. So we've got our x and y-axis, and we've got our first point, which is 3, 8. So 3 across, 8 up, somewhere like that. And then we've got 5, 20. So a little bit across and much further up like that. So we've got 5, 20, and we've got 3, 8. And we want to find the gradient of that line, so the gradient of that straight line. And so what I do is, as before, I would draw a little right angled triangle, like so, and get our rise and our run. So our run, well, we're going from 3 across to 5, so our run is 2. And our rise, we're going from 8 up to 20, so our rise would be 12. So we've got a rise of 12 and a run of 2. So the m equals rise over run, so rise over run. So that's going to be equal to rise 12 over 2 is equal to 6. So the gradient of this line is 6. So for every 1 we go across, we go up 6. And let's just check it. If we went across 1, we would get to 4. And then if we go up 6, we'd get to 14. And then if we went across another 1, we get to 5. And up another 6, we get to 20. So yeah, that's right. Okay, so we know it's y equals 6x plus something, so plus c. Let's just choose one of our points because we know the line passes through both of these points, 3, 8 and 520. So let's choose one of these points. I'm going to choose 520. I could have chosen 3, 8. And I know x is equal to 5 and y is equal to 20. The x coordinate is 5 and the y coordinate is 20. So let's substitute those into our equation. So y, that's 20, equals 6 times x, so that's 6 times 5. 6 times 5 is 30, plus c. So to get c on its own, I'm going to want to take away 30 from both sides. So that will leave me with 20 take away 30 is negative 10. And then we've got 30 plus c, take away 30 just leaves us with c. So c is equal to negative 10, so our y-intercept is equal to negative 10. So our answer would be y equals 6x minus 10. And again, let's just check it. We knew the gradient of the line was equal to 6. So that meant that so for every 1 we go across, we go up 6. So if we're at this point, if we go across 1, we'd go down 6. That would then bring us to 2, 2. If we go across 1 and down 6, that would bring us to 1 minus 4. And across 1 and down 6 would bring us to 0, 10. So yeah, the y-intercept would be negative 10. And that's it. Okay, so let's have a look at our next topic, and it's parallel lines, which is video 196 on corporate maths. And parallel lines, they're lines that go in the same direction and they never meet each other. And because they go in the same direction, they have the same gradient or the same steepness. So if we had y equals 2x plus 1 and y equals 2x minus 3, those lines would be parallel to each other because they've got the same gradients. And this is the Corbettmaths revision card on that. So if you do have the Corbettmaths revision cards, make sure you know this one and stick it up on your wall or bring it with you on the bus in the morning or whatever. Make sure you remember the parallel lines have the same gradient. And that's it. So that's a very useful bit of information that parallel lines have the same gradient, and you can use that in questions as well. Let's go on to our geometry or our shape, space and measure topic. So video 61 is parts of the circle, and we've already looked at the radius, the diameter, the circumference and a chord. Now let's look at some more parts of the circle. So we've got the arc, which is part of the circumference. We've got a tangent, which is a straight line that touches the circle once and carries on. We've got a sector, which is part of the circle, this green region here, or I like to think about it in terms of a slice of pizza. And then we've got a segment. And so a segment is if you've got that chord that goes from one part of the circle to the other part of the circle, and the segment is one of those regions, such as this. Okay, so it's very important to know these parts of the circles as well. And if you've got the Corbettmaths revision card on that, that's very useful. So we're going to look at another one of our compound measures in M3, and that's pressure. So in M1 we had speed, in M2 we had density, in M3 we're going to look at pressure, and that's video 385 in Corbettmaths. And pressure is force divided by area. So pressure is force divided by area, and if you rearrange that, if you multiply both sides of this formula by area, you would get that pressure times area is equal to force. And then if you divided both sides of the formula by pressure, you'd get area equals force divided by pressure. So these are our formula that are very important to know for pressure. Alternatively, if you like using the formulae triangle, it's pressure, force and area. Force goes at the top and you cover up what you're looking for. So if you want to find the pressure, you'd cover up pressure and you would do force divided by area. If you wanted to find the force, you'd cover up the force and do pressure times area. And if you wanted to find the area, you'd cover it up and you'd do force divided by pressure. And these are from the Corbettmaths revision card, so if you've got that card again, it would be quite useful. Okay, let's have a look at a typical question. So we've got a box exerts a force of 4,000 newtons on a table. The area of the base of the box is 250 centimeters squared. Work out the pressure on the table in newtons per centimeter squared. So pressure is equal to force divided by area. So pressure equals force over area, force divided by area. The force is equal to 4,000 and the area is equal to 250. So if we do 4,000 divided by 250, we get, that's equal to 16. So our answer would be 16 newtons, because our force was in newtons and area is in centimeters squared, so it'd be newtons per centimeter squared. And that's it. Okay, let's have a look at another question now. This time we're told a box is placed on a floor And the area of the box in contact with the floor is 1.42 meters squared. And the pressure exerted on the floor is 180 newtons per meter squared. Work out the force exerted by the box on the floor. So the force is equal to the pressure multiplied by the area. Pressure multiplied by area. And in this question, the pressure is 180 newtons per meter squared. And the area is 1.42 meters squared, so multiply by 1.42. And that would tell us that the force would be 255.6 newtons. And that's it. Okay, our next topic. So our next topic is arc length. So in M1 we looked at circumference and area of a circle. In M2 we looked at semicircles, quarter circles, parts of circles, nice fractions of circles. In M3 we could deal with an arc where the angle may not be as nice as a right angle, where it's maybe something like 14 degrees. And the formula to find the arc length, so the length from here round to here, is given by beta, the angle, over 360 multiplied by pi multiplied by the diameter. And this is video 58 in Corbettmaths, and this is part of the Corbettmaths revision card. And our question asks us to find the perimeter of this sector. So here we've got a sector. It's got a radius of 8, so the distance from the center to the edge of the circle is 8 centimeters, and we want to find its perimeter. So we're going to do 8 plus 8 plus whatever this arc length is. So the arc length is beta, so the angle is 14 degrees, divided by 360. Multiplied by pi, and now we're going to multiply by the diameter of the whole circle. So if we did have a whole circle here, the diameter would be 16 the whole way across, so multiply by 16. And that gives us 1.9547 and so on centimeters. So we've been asked to find the perimeter of this sector, so we're going to do 8 plus 1.9547 and so on, and we're going to get our answer. So I've already got this on my calculator display, so I'm just going to press plus 8, and that gives me 17.9547 and so on centimeters. Or if I round it to 2 decimal places, the answer would be 17.95 centimeters to 2 decimal places. And that's it. So to find the arc length, we do beta, the angle, divided by 360, times by pi, times by diameter. And that's it. Okay, let's have a look at our next topic. So the next topic is the area of a sector, which is video 48 in Corbettmaths. And just remember, you do have those practice questions in the link below. So if you do want to practice any of these questions as we're going through, there's questions there for you to try. Okay, so for the area of a sector, here's part of the Corbettmaths revision card. So because the area of the sector is beta over 360, so the fraction of the circle, times by pi, times by the radius squared. So here we've got a sector, and again it's got an angle which isn't necessarily a nice angle. The 90 degrees and the 180 degrees are the ones that you may have seen in M2. So in M3 we've got an angle of 109 degrees, so we're going to have 109 over 360 times by pi multiplied by the radius of the circle. So if we had a whole circle here, the radius would be 0.7 centimeters, so 0.7 squared. And when we do that, we get that's equal to 0.46609 and so on centimeters squared. I'm going to round this to 3 decimal places, so I'm going to write 0.466 centimeters squared to 3 decimal places. And that's it. Okay, let's have a look at our next topic. So our next topic is the surface area of a cylinder, and that's video 315 in Corbettmaths. Now here we've got a cylinder, and we've been asked to find the surface area of the cylinder. Now this cylinder has 3 faces. It's got a circle on the top, a circle on the bottom, and it's got this curved face going around the outside. Now the area of the circles will be straightforward. We'll do pi r squared for the top, and then we'll do pi r squared for the bottom, and they'll also be the same area, so you could just do pi r squared for the top and multiply it by 2 or add it to itself. Now for this curved face going around the outside, if we were to straighten that out, that would be a rectangle, and the height of the rectangle would be 6 meters, and the length of the rectangle, that would be the circumference of the circle. So we're going to get the circumference of the circle and multiply it by 6, the height of the cylinder, and that would give us the area of the curved face. And then we'll add together the 2 circles and the curved face. So let's do that now. So let's start off by getting the area of the circle. So that would be pi times 5 squared, and that will give us the area of the circle, which is 78.53981 and so on. Then we've got the circle at the bottom, and that'll have the same area, so we'll have a circle beneath and that'll have the same area. And then finally we need to find the area of this curved face going around the outside of the cylinder. And to find that, we're going to find the circumference of the circle, so we'll do pi times diameter, so we'll do pi times 10, because the diameter of the circle will be 10, so pi times 10 will be 31.4159 and so on. And then we'll take the circumference of the circle and multiply it by the height of the cylinder, and that will tell us the area of the curved face. So we're going to do 31.4159 and so on, and I've got that in my calculator display, so I'll just press times 6, and that will give me 188.4955 and so on. So I'm going to add together now the area of the circle on the top, the 78.53981 and so on. I'll add another circle, so 78.53981 and so on. And I'll also add the area of this face, the curved face, which was 188.4955 and so on. And when I do that, I get that's equal to 345.575 to 3 decimal places, and then the units, because it's surface area and it's meters, will be meters squared, and that's it. Okay, let's have a look at our next topic. So the next topic is the surface area of a cone. So here we've got a cone, and to find the surface area of a cone, we have to get the area of the two faces, and that's the area of the circle at the bottom, which will be pi r squared, so that's straightforward. And then we need to find the curved surface area, so the area of the top of the cone, and that's given by the formula. Curved surface area is pi rl, where pi is obviously pi, r is the radius of the base of the cone, so that will be 6, and then l is what we call the slant height, so this diagonal length here of 11 centimeters. So let's find the surface area of this cone. So for this cone, we would do pi r squared, so pi times 6 squared for the base, and when we do pi times 6 squared, we get that's equal to 113.097335 and so on. And then, so that's the area of the base. Now we need to find the curved surface area. So it's going to be pi times the radius, 6, times the slant height, which is 11. And when we do that, we get that's equal to 66 pi, or 207.345151 and so on. And when we add those together, we'll find the surface area of this cone, which would be 320.44 centimeters squared to 2 decimal places, and that's it. And one other thing to remember is that this formula is given to you. So this curved surface area of a cone, this pi rl, can be found on the formula sheet in your M3 paper. So whenever you've got your M3 paper, if you turn into the first page, you'll have that formula sheet, and then you can just look on the right hand side and you'll have the volume of a cone, and then it says curved surface area of a cone. Just remember to find the area of the base as well, and to add that on to find the total surface area of a cone. Okay, our next topic. Our next topic is the surface area of a sphere, and again this formula is given to you on that formula sheet. So the surface area is 4 pi r squared. So here we've got a sphere, and we're going to find its surface area. So we're going to do 4 multiplied by pi multiplied by the radius, which is 5 squared. So we're now just going to work this out in our calculator. So we're going to do 4 multiplied by pi multiplied by 5 squared. And that gives us 100 pi, which is equal to 314.16 centimeters squared to 2 decimal places, and that's it. And if you want more practice than this, if you go to video 314 in Corbettmaths, you can watch the video tutorial, and you can try the practice questions and the textbook exercises on the surface area of a sphere. Okay, our next topic. Our next topic now is to find the volume of a cone. The volume of a cone is 1/3 pi r squared h. That means we're going to find 1/3 of pi times the radius squared multiplied by the height of the cone. So in this cone, we've got a radius of 20 and we've got a height of 21. So we're going to do 1/3 multiplied by pi multiplied by the radius, which is 20 squared, and then multiplied by 21, the height of the cone. And when we do that, we get an answer of 2,800 pi, which would be 8,796.46 centimeters cubed to 2 decimal places. And that's video 359 in Corbettmaths. So the volume of a cone, which is given to you on the formula sheet, is 1/3 pi r squared h. Our next topic is the volume of a sphere, and again this formula is given to you. So the volume of a sphere is given to you as 4/3 pi r cubed, and this is part of the Corbettmaths revision card here, and on Corbettmaths video 361. And here we've got a sphere, and it's got a radius of 14 centimeters. So to find its volume, we will do 4/3 multiplied by pi multiplied by the radius, which is 14 cubed. So I'm going to press the fraction button on my calculator, type in 4/3. I'm then going to press multiply by, and then pi times by 14, and then the cubed button, 11,494.04 centimeters cubed to 2 decimal places, and that's it. Okay, so that's how you find the volume of a sphere. The formula is 4/3 pi r cubed. Our next topic is trigonometry. Now it's very important to know the trigonometric ratios, or the trig ratios. which is sine is equal to opposite over hypotenuse, cos is equal to adjacent divided by hypotenuse, and the tan is equal to opposite divided by adjacent. Now some people remember sayings such as Sokotoa. I remember a saying called two old angels skipped over heaven carrying a harp. That's what I was told in school. And I like to use these triangles. Now some people just remember the ratios, these sine equals opposite over hypotenuse, and rearrange it, and that's totally fine if you do it that way. I like to use the triangles whenever I'm doing it, so I remember two old angels. So I put the T and then the O at the top and then A for angels there. Skipped, so the S for sine, over, O at the top, heaven, so the H there, so skipped over heaven, carrying a harp. And that's how I remember my triangle whenever I'm doing trigonometry questions. If you just want to learn the ratios and rearrange them, that's up to you. So these are videos 329, 330 and 331 on Corbettmaths. Okay, let's have a look at some questions. So here we've got a trigonometry question, and I know it's a trigonometry question because we've got a right angle triangle and we've been asked to find the size of this angle x. Now it's not going to be Pythagoras because Pythagoras will just be dealing with the sides of the right angle triangle, and angles are involved in this question. So the first thing I would do on a trigonometry question is label the sides. So we've got the angle here, which is x, so the side opposite that will be the opposite, so this side opposite it is called the opposite. Then we've got the hypotenuse, and the hypotenuse is the longest side of a right angle triangle, so that will be this 10, that's going to be h for the hypotenuse. Then finally, the other side is called the adjacent, and that is the side beside the angle that we haven't labelled yet, this A. So in this question, we've got 8, which is the adjacent, and we've got 10, which is the hypotenuse, and the opposite isn't being used. So we're dealing with a question which involves A and H. So we've got two old angels skipped over heaven carrying a harp. Now, as you notice, we're not using the opposite in this question. It's not been given to us and it's not been asked for. So we're not going to be using the triangles involving O. So we're not using that triangle, that triangle. So this is a cos question. We know that we're dealing with cos, adjacent and hypotenuse. Now we want to find the size of this angle. So we want to find what this angle is. So we cover up the cos. We want to find the cos of the angle. So you cover up the cos and we know that's equal to adjacent divided by hypotenuse. So cos of the angle, so cos x, equals the adjacent, so A, divided by the hypotenuse, h. So cos is equal to adjacent divided by hypotenuse. Now we can substitute in our values for A and h because we know that A is equal to 8 and h is equal to 10. So we get cos x is equal to 8 over 10. Now we know that the cos of the angle is equal to 8 over 10, or that's 0.8. And obviously this angle isn't 0.8 degrees, so we want to find the angle, so we want to get rid of this cos. So whenever you want to get rid of the cos, you do the opposite, which is the inverse cos, or the cos with the little -1 on your calculator, and it can be found in yellow just above where it says cos. So you press shift on your calculator, and then you press the cos button, and it'll appear like this, with a cos and a little -1, and then you just type in 8 over 10, like so, 8 over 10, and then press equals. And when you do that, you get an answer of 36.87 degrees to 2 decimal places, and that's it. So in this question, the first step was I labelled the sides, opposite, hypotenuse and adjacent. I then listed my triangles, and I crossed out any that were involving the opposite because we weren't dealing with the opposite in this question. And because we were finding the angle, then I wrote cos x equals adjacent divided by hypotenuse. I then done the adjacent divided by hypotenuse, which is 8/10 or 0.8. And then finally, because we want to find the size of the angle, I press shift cos and then type in that 8 over 10, or you could type in 0.8 and press equals, and you get the size of the angle, and that's it. Okay, let's have a look at another trigonometry question. So again, we've got another right angle triangle. We've got our 60, we've got our 4 kilometers, and we've got our x. So let's label the sides. So the side opposite the right angle is called the hypotenuse. The side opposite the angle given to us is equal to the opposite, and the side left over, this side here beside the angle, is called the adjacent. So we've got two old angels skipped over heaven carrying a harp. Now in this question, we've got the 4 beside the hypotenuse and we've got the x beside the opposite. The A, the adjacent, doesn't have any side that we're looking for or being given, so we're not dealing with the adjacent in this question. So let's cross out any triangles that have the A involved. So this is a sine question where we've got sine, opposite and hypotenuse. Now in this question we want to find the opposite. So we go to the triangle and we cover up the O and we get sine multiplied by the hypotenuse. So it's the sine of the angle, so sine 60 multiplied by the hypotenuse, which is 4. So the opposite is equal to sine 60 multiplied by 4. When we type in sine 60, and make sure you close your brackets, multiplied by 4, we get an answer of 3.464. And this question, our units were kilometers, so the answer would be kilometers, and that's it. Okay, so our next topic is product of primes, and that's video 223 in Corbettmaths. Now in M3 we use the product of primes to work out the LCM, that's the lowest common multiple, or the HCF, the highest common factor. So let's have a look at our first question. So let's write some numbers as product of primes, and then we'll use that information to find the lowest common multiple and the highest common factor. So our first part says write 92 as a product of primes. So I'm going to do my prime factor tree. Remember, you can do the upside down bus shelter method if you wanted to. So 92, that's 2 times 46. Let's circle the 2. And 46, that's 2 times 23. And they're both primes, so let's circle them. So 92 as a product of primes would be 2 times 23. And in index form, that would be 2 squared times 23. Now our next question is to write 48 as a product of primes. So I'm actually going to use my calculator to write 48 as a product of primes. So on my calculator, I've got this yellow fact there. So what I do is I press 48, then press equals, and 48 comes up in my calculator display. Then I press shift, and then where it says fact there, and on the display it will show me 2 to the power 4 multiplied by 3. So 48 equals 2 to the power 4 times 3, or 2 times 2 times 2 times 2 times 3. So we've got 92 as a product of primes, and we've got 48 as a product of primes. Let's now use that information to work out the lowest common multiple and the highest common factor of those numbers. So here we've got our question. It says write down the highest common factor of 48 and 92 and write down the lowest common multiple of 48 and 92. So let's write down what they were as product of primes again. So 48 was equal to 2 to the power 4 multiplied by 3, or if we wrote it out in full it would be 2 times 2 times 2 times 2 times 3. And 92 was equal to 2 squared multiplied by 23, or in full 2 times 2 times 23. Now let's put those numbers in our Venn diagram. So here we've got a Venn diagram, and we've got one circle for 48 and we've got one circle for 92, and we're going to put their prime factors into this Venn diagram. So first of all, let's see if they share anything. So as you can see, 48 is 2 times 2 times 2 times 2 times 3, and 98 is 2 times 2 times 23. So they've both got 2 2's. 92 has got 2 2's, and 48 has got 2 2's. So we're going to put 2 2's in the middle. Now, as you can see here, 48 had 2 more 2's, so let's put those 2 2's in the 48 side. 48 also had a 3, but 92 doesn't, so let's put the 3 there as well. And finally, 92 has a 23, so we'll put that into the 92 side. So as you can see, in both circles, we've got 48, and we've got 2 times 2 times 2 times 2 times 3, and that's 48. And for the 92 circle, we've got 2 times 2 times 23. So you put what they share in the middle, and then you put the extras onto each side. So the first question says work out the highest common factor of 48 and 92. So to find the highest common factor, we multiply the prime numbers in the middle. So we're going to do 2 times 2. So the highest common factor will equal 2 times 2, and 2 times 2 is equal to 4. So the highest common factor is 4. Okay. Our next question says to work out the lowest common multiple of 48 and 92. So to find the lowest common multiple, we multiply all the numbers in the Venn diagram. So we're going to do 2 times 2 times 3 times 2 times 2 times 23, or in order, the lowest common multiple equals 2 times 2 times 2 times 2, because there's 4 2's, times 3 times 23. And when we do that, we get that's equal to 1104. So we've worked out the highest common factor and the lowest common multiple of 48 and 92 really quickly and easily by using this Venn diagram. So what you do is you write each number as a product of primes, you put the numbers into the Venn diagram, and make sure whichever ones they share go in the middle, and put the extras on each side, and that's it. And to find the highest common factor, you multiply the prime numbers in the middle, and to find the lowest common multiple, you multiply all the numbers in the Venn diagram. Okay, let's have a look at our next topic. So our next topic is reverse percentages, and that's video 240 on Corbettmaths. And remember, you can watch that video tutorial, video 240 on Corbettmaths, and I will go through reverse percentages in a lot of detail. Also, beside that video 240 on Corbettmaths, you'll find the practice questions, which are really great because they will have a lot of curveball questions in there, which are really fantastic to do. I'll have the textbook exercises, and I'll have the answers as well. So video 240, and also remember there's reverse percentages questions in that bumper pack of questions, that M3 booklet, which is in the description below. So here's a typical reverse percentages question, and it says Rebecca is given a 35% pay rise. She is now paid $13.77 per hour. What was Rebecca's pay before the pay rise? So to do this, what we need to do is consider the fact that we have increased her pay by 35%. So that means she now has 135% because she had 100% before pay rise, and then she's given a 35% increase, so she's now got 135%. And 135% is equal to £13.77. Now to find what her pay was before, we want to find 100%. So let's find 1% and then find 100%. So if we know what 135% is, we can divide by 135. We can divide by 135 and we can divide by 135. And when we do that, we get 1%, and 1% is equal to 0.102 pounds. And then we want to find what 100% is, so we'll multiply by 100. So let's multiply by 100, and let's multiply by 100. And when we do that, we'll get, well, 1% times by 100 is 100%, her pay before the pay rise. And whenever we multiply 0.102 pounds by 100, we get that's equal to £10.20. So Rebecca's pay before the pay rise was £10.20. Now there is another way to do this, and in the M2 video I went through a topic called multipliers, and to increase by 35% we use a multiplier of, we multiply by 1.35. So if you want to go backwards and find what number was increased by 35%, we could divide by the multiplier. So if you do 1377 divided by 1.35, you'll also find £10.20, and that's it. Okay, next topic. Okay, let's have a look at our next topic. So our next topic is upper bounds and lower bounds, and that's video 183 on Corbettmaths. Sometimes we're given a number after it's been rounded. So here we've got the height of a building is 18 metres to the nearest metre. So that means that the building could have been exactly 18 metres, but it could have been actually a bit shorter than 18 metres. It could have been 17.9 metres. It could have been 17.7 metres. It could actually be 17.5 metres. And that's the lowest value that it could be. It could be 17.5 metres because that rounds up to 18 metres, but it couldn't be anything below that because that would then round down to 17 metres. So that's called the lower bound, the lower boundary. In terms of numbers above 18 metres, it could have been 18.1 metres, it could have been 18.34 metres, it could even be 18.497 metres. It could be anything up to, but not including 18.5 metres, because it could be anything up to that, but it couldn't actually be 18.5 because that would round up to 19 metres. But 18.5 is the boundary, it can go up to that value. So the lower bound for the height of the building, the lower bound would be equal to 17.5 metres, and the upper boundary would be 18.5 metres, so it could go up to 18.5 metres. Sometimes this is written as a thing called an error interval, where the height of the building is anything that is bigger than or equal to 17.5 metres, but less than 18.5 metres. This is what we call the error interval, and it just shows what the values could have been. The height of the building could be anything that's bigger than or equal to 17.5, but less than 18.5. And these are what we call the boundaries, the lower bound and the upper bound. Okay, let's do a question now which uses bounds. So here's a typical question. It says the length of a field is 120 metres to the nearest 10 metres, and the width of the field is 70 metres to the nearest metre, and we've been asked to work out the lower bound for the area of the field. So it's a rectangular field, perhaps I should have said that in my question, it's a rectangular field, and to find its area we're going to multiply the length and the width together. And we want to find the lower bound, so we want to find the lowest possible area of the field. So let's start off by looking at the length of the field. We know it's 120 metres to the nearest 10 metres. So its lower bound, the lowest possible value that it could be, would be 115 metres, that's the lower bound. And the upper bound for the length of the field, well, the upper bound would be 125 metres. In terms of the width of the field, well, this has been rounded to the nearest metre, so the lower bound for the width of the field would be 69.5 metres, and the upper bound for the width of the field would be 70.5 metres. So they are the bounds, and we've been asked to work out the lower bound for the area of the field. So the lower bound would be the smallest possible area. So we would do 115 multiplied by 69.5. So we're going to do 115 metres multiplied by 69.5, and that will give us the lower bound for the area of the field. So we'll do 115 multiplied by 69.5, and that equals 7,992.5 metres squared. So that's the lower bound for the area of the field. If we were asked for the upper bound of the area of the field, we would do 125 metres multiplied by 70.5, and that would give you the upper bound for the area of the field. Okay, our next topic. Okay, let's look at our next topic. So our next topic is called quartiles, and that's video 57A in Corbettmaths. Now, we've looked at the median before, and the median is the middle value. So if you've got a set of data, if you've got a set of data, the median is the middle value. If you've got a set of data and you're looking for the quarter value, that's called the lower quartile. So if you arrange the values in order from the lowest to the highest, a quarter of the way into the data is called the lower quartile, and 3/4 of the way into the data is called the upper quartile. Now, those are very useful for working out a thing called the interquartile range, and I'll talk about that in a minute. So the median is the middle value, The lower quartile is a quarter of the way into the data, and the upper quartile is 3/4 of the way into the data. Now to find the lower quartile, I tend to put them in order. I find the median, and then I find the median of the lower half of the data. And for the upper quartile, I again range them in order. I find the median. I work out the median for the upper 50% of the data. And also I mentioned a concept called the interquartile range, and the interquartile range is worked out by working out the difference between the upper quartile and the lower quartile. So if you do the upper quartile, subtract the lower quartile, we get the interquartile range. Now maths, again, you've seen a topic called the range before, which is the highest value subtract the lowest value, but sometimes there's outliers, and that will affect the range massively. If there's one value which is really, really big, for instance, and the rest are much lower, whenever you work out the range, you get a really large range. Well, if we work out the interquartile range, so the difference between the 3/4 of the way through the data and a quarter of the way through the data, and you subtract those, that will tell us how spread out the middle 50% of the data is, and that's really useful because it means that the sort of the effect of outliers is reduced or eliminated. So let's have a look at some data. So we've got 5, 5, 6, 8, 9, 10 and 12. And let's find the lower quartile, the upper quartile and the interquartile range. So if I wanted to work out the lower quartile to begin with, well, first of all, we know that 8's the median. So 8's the median here. And then if we look at the bottom 50% of the data, we've got 5, 5 and 6. So the lower quartile would be 5. And in terms of the upper quartile, well, that would be 10. So the lower quartile would be 5, the upper quartile would be 10, and the median would be 8. And that's the lower quartile, and that's the upper quartile. And if we wanted to work out the interquartile range, we would just do the upper quartile, 10, subtract the lower quartile, 5, and that gives us an interquartile range of 5. Okay? Now these ideas of quartiles, lower quartiles and interquartile range are very useful in M3 on a topic called cumulative frequency curves or graphs, and I'll talk about those in a second. So let's have a look at our next topic. Okay, so our next topic is cumulative frequency. So that's videos from 153 and 154 in Corbettmaths. So I'd highly recommend you watch those videos because this is a very important statistics topic. Now, in terms of the words cumulative frequency, I remember whenever I was younger, I looked up what cumulative frequency meant in a dictionary. This was before the days of the internet, and it said running total. So the cumulative frequency is the running total. So here we've got our frequency table, and it's a group frequency table, and we've got the lengths of some items, and we've got 0 to 5 centimeters, 5 to 10, 10 to 15, 15 to 20, and 20 to 25. And we're given the frequency, so we know it's 3 in between 0 and 5, 10 between 5 and 10, 21 between 10 and 15, and so on. And sometimes we're asked to complete a cumulative frequency table. So it looks something like this. We've got the length, but this time instead of going 0 to 5 and 5 to 10, it goes 0 to 5, 0 to 10, 0 to 15, 0 to 20, and 0 to 25. And we may be asked to fill in the cumulative frequencies. So that's the running total. So we know there's 3 in between 0 and 5. So that means that the cumulative frequency would be 3. Now in terms of 0 to 10, well, we know there's 3 between 0 and 5 and 10 between 5 and 10. So if we add those together, 3 plus 10, that means there's 13 altogether between 0 and 10. Now, from 0 to 15, well, we know there's another 21. So if we add 21 on, we'll find the cumulative frequency. So 13 plus 21 is 34. We know there's another 4, so that's now going to be adding on 4, 38. And adding on 2 would be 40. So we've completed the cumulative frequency table. Now let's draw the cumulative frequency curve. Now, this is sometimes called cumulative frequency curve or cumulative frequency graph. I tend to call it the cumulative frequency curve because it's quite nice to draw a nice curve through it. So to plot the points for the cumulative frequency curve, we're going to plot each of these cumulative frequencies at the end of each of these groups. So we're going to go 5 across and 3 up, 10 across and 13 up, 15 across and 34 up, 20 across and 38 up, and 25 across and 40 up. We know these are the cumulative frequencies up to the end of each of these categories. So 5 across and 3 up, 10 across and 13 up, 15 across and 34 up, 20 across and 38 up, and finally 25 across and 40 up. So our points would look something like this. Now we're going to draw a curve. Now in terms of your curve, you're going to start at the bottom of the first category. So it starts at 0. So we're going to start at 0 here. And we're going to go up and do a curve going through the points like so. And this is quite tricky on the computer, but like something like that. So that's our cumulative frequency curve. Now sometimes after we draw a cumulative frequency curve, we're asked to work out things such as the median, the lower quartile, the upper quartile, the interquartile range, and so on. So let's have a look at those now. So now we're going to find those medians, lower quartiles, upper quartiles, and interquartile range for a cumulative frequency curve that I've already drawn for us. And it's for pocket money. And altogether, there's 600 children, and the pocket money goes all the way up to £12. Okay, let's start off by finding the median. So the median is the middle value. Now this is grouped frequency, so we can just divide the frequency by 2 to find the position of the median. So for 600, we're going to divide it by 2, so that's the third hundredth value. So we go to 300 on the cumulative frequency axis, and we'll go from 300 across the curve, and it looks something like this, and then down. And make sure you do that with a ruler and a pencil, and we'll find that we're exactly halfway between this 6 and this value here. That's £6, that's £8, so that's £7 in the middle, and we're exactly in the middle of those, so it's going to be £6.50. So our median amount of pocket money is £6.50. Now our lower quartile, well, altogether there were 600 children, and the lower quartile will be a quarter of the way into the data. So we're going to divide 600 by 4 to find the position of the lower quartile. So 600 divided by 4 is equal to the 150th value. So we're going to go from 150 across and down. And when we do that, we get to £5. So the lower quartile is £5. The upper quartile, well, that's 3/4 of the way through the data. So we're going to work out 3/4 of 600. But we know a quarter is equal to 150. So if we do 3 times 150, that's equal to 450. So we're looking for the 450th. So if we go across from 450 and down, we get to £8. So the upper quartile is £8. And finally, we've been asked to work out the interquartile range. So that's how spread out the middle 50% of the data is. So the upper quartile is 8, the lower quartile is 5. So we're going to do 8 take away 5, and that's equal to £3. So the interquartile range is £3. And that's it. Okay, so let's have a look at some more questions that you may be asked on cumulative frequency. So you're often asked to find the median, the lower quartile, the upper quartile, and the interquartile range. But sometimes you're asked other questions. So let's have a look at another question now. So here's a cumulative frequency curve. It's the same one with pocket money and cumulative frequency. We've been asked to estimate how many people earned less than £6. So if we go from £6 up and across, we get to 240. So that means that up to £6 there was 240 children. So how many children earned less than £6? Well, the answer would be 240. And this is an estimate because this would have been group data and we don't know the exact figures, so this is why it's an estimate. Okay, our next question. Our next question says estimate how many people earned more than £3. So if we go from £3, which is in between 2 and 4, so here and up and across. So we've gone to £3, we've gone up and across, and that tells us that 40 children earn up to £3 pocket money. So in terms of an estimate for how many children earn more than £3, that should be the rest of them. So there was 600 altogether, so if we do 600, take away 40, that's equal to 560. So our estimate for how many children earn more than £3 pocket money would be 560. Okay, our next question. Our next question says, estimate the amount of pocket money that 100 people receive less than. So we're going to go from 100 people across and down. And when we do that, we get to the second square across after the 4. So we know 5's there, so there's going to be 1, 2, 3, 4, 5. So there's 5 squares for £1. So £1 divided by 5 is 20p. So each square is 20p, and we've gone to the second one there. So it's going to be £4.40. So we've got £4.40. So that means that the 100 children who receive the least amount of pocket money will receive less than £4.40. And that's our estimate. Also, make sure you use a pencil and a ruler for this. I'm doing it freehand on the computer, so make sure you're using a ruler and a pencil whenever you're doing these questions. Okay, now next topic. So we've looked at cumulative frequency. Now cumulative frequency links into another topic called box plots, or sometimes you'll see them called box and whisker diagrams, but I tend to call them box plots, and that's video 149 and 150 in Corbettmaths. So this is a box plot, and a box plot has 5 vertical lines. We've got a line for the lowest value, a line for the lower quartile, a line for the median, a line for the upper quartile, and a line for the highest value. So we've got 5 vertical lines, and the 3 in the middle, the lower quartile, the median, and the upper quartile, are joined up into a box like so, where a line will go horizontally at the top and the bottom. And then there will be 2 lines going out to the lowest value and to the highest value like so. So this is called a box plot. And one of the benefits of box plots is you can see how the data is spread out, because between each pair of vertical lines, 25% of the data lies. So in between the lowest and the lower quartile, there'll be 25% of the data. Between the median and the lower quartile, another 25. Between the median and the upper quartile, another 25. And between the upper quartile and the highest value, another 25% of the data. So box plots are really useful ways to represent data. This is the Corbettmaths revision card. So if you do have that revision card, make sure you have that and you sort of learn it and bring it to school with you. Make sure that you know how to draw and to read a box plot. Okay, let's compare 2 box plots now. So here we've got two box plots and they show the reaction times of two groups. So we've got group A and group B and we've got their reaction times. The quicker someone's reaction times, the less time it takes. So values down to the left hand side here are really good. That means someone's got quick reaction times because it's taken less time to react. And values over to the right hand side means they're a bit slower. Now if I was to compare these box plots for group A and group B, the first thing I notice is the medians are the same. So that means that their average, the median, reaction time is the same. It's equal to each other. But another thing that I notice is that this group A is much wider. It means it's much more spread out. So it means there's some people with really fast reaction times, and then you've got some people with really slow reaction times. So they're much more spread out. And you can see that by particularly the box itself, because that represents the middle 50% of the data. And it goes from 0.2, the lower quartile, up to 0.35. So the interquartile range here would be 0.15. Whereas if we have a look at this box, the interquartile range is much smaller because our lower quartile is 0.24 and our upper quartile is 0.33. And if we take those away, that's much smaller. So if I was comparing two box plots, I would first of all look at the medians and see how they compare. So here we can see the medians actually equal to each other. So it tells you the average is the same, but you can see that the data is much more spread out for group A than group B. Okay, and our last topic is called samples, and that's video 281A in Corbettmaths. Now samples can be very, very useful. Rather than surveying or interviewing everybody, for instance in a school if you wanted to find information about what colour blazer you would like, rather than asking every single student, it can be very useful, and that's called a census, asking everybody in a population. Rather than doing a census, you can do a sample where you ask a smaller number of people. But it's very important whenever you do samples, they're fair. So, for instance, if I was doing a survey of students about blazers, it's making sure that you ask people from different year groups, you ask a range of different classes. So it's very important that you get a good sample, a fair sample, to make sure that your sample is representative of the whole population. But here we've got a question and it says 480 students attend a school and a teacher asks 50 students which colour blazer they would like. So we've got black, 20 students would like a black blazer, 15 students want a navy blazer, 9 students want a green blazer and 6 students want a maroon blazer. And the question says estimate how many of the 480 students would like a navy blazer. Now altogether we knew there was 50 students altogether and we want to work out an estimate for how many students would like a navy blazer. Now if I look at the sample, we know that 15 out of the 50 wanted navy. Now if we work out 15 over 50 as a fraction, that's equal to 3/10. So that means that 3/10 of the students asked would want a navy blazer. Now if this was a good sample, a representative sample, that means that it should be the same fraction of the whole school would want a navy blazer. So if we work out 3/10 of all the students in the school, we'll find out how many should want a navy blazer. So if we work out 3/10 of 480, that would tell us a good estimate. So we'll do 480 divided by 10, that's equal to 48, and then we'll do 48 multiplied by 3, and that's equal to 144. So that's it. If we were asked how many of the 480 students would like a black blazer, we would have done 20 over 50, which is 2/5, and then work out 2/5 off the 480 and so on. Okay, so that's it. So we've just gone through all the M3 topics. We've spent 3 or 4, in some case 5 or 6 minutes on each of the topics, and I hope this video has been really, really, really useful for you. This checklist is really useful as well. Make sure you print it out and you keep it as part of your revision, and also make sure you go through the M2 topics and M1 topics as well. It's useful to print out those checklists and to watch those videos on Corbettmaths as well. So I hope this video has been really useful. Remember, there is that bumper pack of questions, that Ultimate CCEA M3 revision question booklet. I know, catchy title. But that booklet will be very useful for you because, you know, while you've been watching this video, you may have written notes, but it would have been really useful to do questions as you went through. So watching the part of the video on reverse percentages, then try the question, check you've got it right, and so on. Also remember, the higher revision cards might be very useful for you, so you might want to have a look at those. And in terms of the 5-a-days, and rather than cramming your revision for M3, I would highly recommend looking at the Foundation Plus and the higher 5-a-days. And that's it. So as I said, I hope this video has been really useful for you. Good luck with your revision, good luck with your studies. Please subscribe to Corbettmaths on YouTube, please like this video, and thank you so much. Good luck.